I've been on mute this whole time. Nobody told me. Okay, so. Um, real quick, as I said, we showed how to do install Python, Q Python 3L if you're on smartphone. Showed you how to start idle, showed you what variables are, math operations, just like what you learned in high school. Input output with our print and inputs functions. We even covered a bit of file input output with the with open function as whatever your file label is. We'll come back to that, get into some more details. We're going to move on to conditions, though. That's what I'm doing here. Alright, this is your basic condition statement. Starts with a if keyword, followed by something to be tested. Our label, we want to do a comparison against the value of, what's on the other side. If this evaluates to true, and not just, the value of does it is true, although in this case that would be what makes it true, it'll execute this code block here. Now, it doesn't help to try to evaluate a variable that you've never used before. Also, if you're doing comparisons, two equal signs. Because if you only use one, that's an assignment, and this right here, what's in parentheses here, will always be true if it's assignment. Like, it doesn't matter, you put does it equals, apple tree. That'll still be a true statement because it's an assignment. It executes, therefore it's true. This is comparison. Double equal signs. The way you can remember that is equal. Whereas this is our label does it is true. Our label is equal to true. Okay, so let's test this out and see what it does. It did nothing. Why did it do nothing? It did nothing because up here, as you can see, our label, our variable, is actually false. Therefore, this statement is not correct because this does not equal this. So this would evaluate to false. So, because we only want this code block to execute if what's in the parentheses here evaluates to true, it didn't run it. It simply didn't run it. Now, probably not the clearest way to do that, but, here's another example. Still does nothing. Why? Because is it simply is not equal to 3. It's equal to 5. We set it as 5 before this statement. Now, if I go ahead and change that to 3, you bet it does. We have no idea what they're talking about here because unless we've read the code. But as you can see, once what's in the parentheses becomes a true statement, the code block following is executed. Now, what if you wanted to execute something else if that statement was false? Well, you can set up a second code block following your if using the keyword else. I'll set that back to 5. And ta-da! Notice that it skips over this first code block because this executed and evaluated to false. What's in parentheses here? And we don't actually need the parentheses. I prefer to put the parentheses because it helps to better define the condition that I'm testing, at least when I read it. Because you'll see this doesn't change anything. See? But anyway. So if keyword, the condition following, double equal signs, just is this that. The code block that follows immediately after, executed if true. If you set up an else code block following your if code block, and what you have evaluated is false, it'll execute what's there. This is entirely optional, the else code block. You don't need it. But it does come in handy. Highly recommend them if you need them. Don't write yourself 1,000 different ifs just testing the various things when you can just do with a simple, well, if this one's false, then, print, whatever. Now, we can get even fancier with this. What if we have multiple possible values, and we want it to do something different for each value that this could be? Well, what we've got here as you can see, just by changing this this value, we're able to get multiple different outcomes. Now, it is imperative that you are careful with how you set up the logic for your if statements and the order in which you evaluate things. Because as you can see here, when I set this to... well, when I set it to 2, this statement is correct, but so is this one. Let's see what happens when we change those around. it still says small. And it will continue to say small no matter what we put there. And the reason why it does that is because this first statement evaluates to true. And because that evaluates to true, this one's ignored and this one's ignored. So be careful what order you're putting things in if you're using the if, else if, which is just elif. It's just a shortening of else if and else. Because logically, it has to make sense. Otherwise, you're gonna run into an issue where you'll have options that'll never execute, no matter how much you want them to. I hope that makes sense. I hope that makes some kind of sense. Anyway, Python also has kind of an interesting shortcut when using the true-false things, because as you notice, that's a value. And that's a value. These are called booleans. It's just a true-false set of values that you'll see a lot in programming. Because a lot of the time, you just need to know if something's true or if something's false. And so they've just made that a data type that you can use. And it's not just in Python, it's pretty much every programming language. The ones that don't have a Boolean data type, they would often do things by having it be 0 or 1. And you'd have your flag variable set to either 0 or 1. 1 being true, 0 being false. And then you would just, when you do your logic test, if your variable was 0, the code doesn't execute. If it's set to 1, it does. We'll be using booleans for our purposes here, though, because, we have them available. Python is conveniently equipped with that data type. Please note it's a capital F and capital T. Other programming languages, it might be a lowercase f, lowercase t. If you're coming from like a JavaScript, sort of background, and you're running into a lot of syntax errors when doing any of the following, check to make sure that you capitalize stuff properly. It's probably just that simple. Alright. So, that's basically how to do conditions. Some programming languages you might be familiar with a switch statement that gives you a whole long list of options for, you can set your variables to any number of things. With Python, it's just a series of if statements, really, with just elif, 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 and then your else block at the end for a default if none of the values before it are true. We don't have a switch statement, but we can execute the exact same stuff without it. Anyway, given what we learned in the last video, I think we're ready to tackle our first major project. Now, the concept I want to introduce you to here is something someone brought up in the last video chat. How do you get started with a project? So you're not just staring at a blank canvas, not really knowing what the heck you're doing. Well, thing to do there is to plan out your project ahead of time. By the time you get to typing it out, you should have a concept in your head of what you want your program to do. And then when you get to here, you're going to break that up into the various steps that need to be performed by the computer to do the thing you want it to do. Now, last session we did a little bit with files. Not much. We were just playing around with a list of cat names. Not real exciting. This time, I want to be able to tackle functions and objects a bit more. We're going to talk a bit more about this file input-output. We're also going to talk about print statements a little bit more. They can get fancy. They can get a little fancier than what I've shown you. And you're about to see some of that. When we're done with this project, we'll have something that we can import into other projects later, which will be quite cool. Quite interesting. Alright, so what are we going to make? We're going to make a simple database program that uses those text files that we've been playing with. Now, one very simple, database sort of schema as to how to set up something like that. You might see it referred to as a CRUD. C-R-U-D. Those letters stand for create, read, update, delete. So, those are going to be the functions of the program that we're about to write. And when I say functions, I do kind of mean in the literal sense of these are going to be bits of code that we're going to call on, and they'll execute those tasks for us. So, we're going to start with my favorite way to set up any Python script, and that's by preparing for it to be a library that we can call in something else. Now you might recognize this as being an if statement. I mean, we've already seen an if statement, but we haven't seen me define name before, and we're not going to now either. This is a special variable that is assigned every time you run a Python script. Usually when you run the Python script, your variable or your name variable will be set to the value of main. Because the name for the script you're running is going to be in the system's memory, main. So, this script, when we run it, if we're running it directly from this script, like we just execute this script, and this is the script that launches everything, if that's going to be the case, the name module should be given the value main. Oh, by the way, we're going to call this program CRUD Buddy. I know. Seems a bit weird, but it'll all make sense in the end. Just follow along. Trust me. Trust me. Alright, so we've already got a statement here that we can run. We can test this. So let's run that module. Welcome to CRUD Buddy. Okay, so clearly our special variable name, which we don't have to define, that's just something Python does in the background, is already set to main. It runs this code block, prints our little welcome message. That's all fine and good. But now, like I said, we're going to do a little file manipulation, and we're going to be using these operations to maintain our file. So, first thing we're going to want to do is we're going to want to get a file name from our user, probably. I mean, if we're going to use this, as our main script, we would get that information from the user. If we import our functions into another program, we may get that name from somewhere else. But for the purposes of this one, we're going to go ahead and we're going to ask the user to enter a file. Now, if the file exists, before we go ahead and have Python overwrite whatever's there or make changes to it, we should probably just double check with the user that, they really want to use that file. So what we're going to do is we're going to start by creating a couple of checks. Okay, so we haven't talked about this yet. This is the import statement. This is a keyword that allows us to bring into the script we're currently writing a library of functions and things that somebody else has created. In this case, we're importing the module OS, operating system. Somebody wrote a very useful library that checks to make sure, files exist and, things like that, and allows you to exit your program, safely for whatever operating system you're working with. It's a very handy library. You don't need it for everything, though, but for our purposes here, we're going to want to use it. Now, one thing I also want to do is I want to make sure that we are just operating in this folder. This is just kind of a safeguard. So what I'm going to do is I'm going to establish a directory. Now you may remember from last time, we had this whole big long string path for our files. We're going to eliminate that with this, and at the same time keep us contained to this one folder. So, we've set up a working directory, given it a label. At some point we may write functions to change the file directory. But for now, we want to keep the power of our CRUD buddy confined to this one folder. Now, I want to make sure I'm doing this right. And yes, I pulled this up earlier because I wanted to make sure that I'm doing this right. You know what? We're going to use exists. I think it helps with the readability. Oh, we should be using the path. Although we're also going to use that, because at the end of all this, I want to be able to do. Whoop. Well, shoot! Now I don't remember how we exit. Okay. Yeah, that'll work. Sorry, I don't usually have to exit stuff that way. But for our purposes here, I want to be able to. Alright, so when our program hits this, it's going to exit. Alright, now when our program hits this, see, we'll want to use our file here. I believe we want to use the full file name. Ugh, where's my window? There's my window. Okay. What we're going to do is now you might be thinking to yourself, why are you doing arithmetic with strings? Because you can. The addition symbol in Python, when it's adding two strings together, what it's doing is it's taking the first and it's appending the second. So it'll take this and attach it to the end of this, and that'll cause all of this to evaluate into a value that can be used by this function to tell this keyword if the file we're looking for exists. Okay. Unterminated string literal. Did I forget to put a... I did. Always make sure that the beginning and end quotes match. Otherwise you get an error that's like that. Okay. So, run that. Enter a file name. Okay, as you can see, success. This file exists. We have passed our first check Okay, but let's correct this error issue we have here. It says sys is not defined. Usually when you come to something like that, it's because you're trying to use a module like I am here that you haven't imported yet. There we go. Hooray! Let's see what happens when we try entering a file name that doesn't exist. Nothing. Okay, so that's accurate. That is correct. Everything's working there. So, what we would like to do is, if the file does not exist, we would like to create the file. So, let's do that. Alright, so if it doesn't exist, we should ask first. We should also let the user know that we didn't find the file. All right. Now, it helps to be accurate. And it helps to be informative. With your prompts. So now if we run this, there we go. Sorry, the exclamation point means not in pretty much every other programming language I'm used to. I often forget Python just uses the keyword not. So, if not OS path exists, file directory plus file name, it should say print file not found. Confirm create, ask us to, if we would like to create it. So, once again, doggos. File not found. Create file now? Yes. Okay. Now, for now, that really doesn't do anything. All we're doing is we're getting the confirmation of whether or not we would like to proceed with file creation. Now, if we run this module again, and we ask for a file that already exists, why is it saying... Hold on, that's weird. Ah, there we go. It doesn't come up with that. Doesn't do the thing. Let me run that one more time so you can see that that was a miss key that caused it to do the weirdness that you saw there. See? The file exists, it's not going to ask us to create it. If the file does not exist, it does ask us to create it. Now, we haven't written our file creation thingy yet. We probably should, though. now that we have it. So anyway, for that, we're going to do a function. But before we do that, I want to put this into a loop. Let's see. How do I want to word this with the prompt? Now you might be noticing I do one capital, I do one lowercase here for a yes or no. The reason for that is it's been standard practice in Linux for a while now, where the default answer is capitalized. So if you just hit enter, it'll automatically go with the capitalized one. If you want to not go with the default answer, you actually have to physically type something in. You can't just hit enter and have it expect to know that you want to quit. You actually have to tell it you want to quit. So now, I talked a little bit about lists in our last one. They're a data type. If you're familiar with programming in other languages, they're quite similar to an array. It's a list of possible values, each one indexed, starting at 0 and progressing 1, 2, 3, 4, 5, etc. For the entire length of the list. They're great for when you have multiple options. Very handy if you need to iterate through a few different options, or if you have a few options to choose from. For example, here we want to change done to true in the event that our user has selected any of these common answers, indicating they want to get the heck out of here. If they just hit enter, it's going to ignore all that, and it's just going to loop through. In theory, Anyway, let's see if that actually worked. Okay. File not found. Create it now? Why, yes. Do we want to exit? No. Enter a file name. Kittens. No need to ask if we want to create the file. Exit. And it exited. And we could test that for all of these possible options here. Run the module. Helps if I spell kangaroos correctly. There you go. So that's how you can create a multiple input option. And we're going to do that again when it comes to the creation of the file. Except all of our options are going to be, instead of yes, we're going to have an extensive list of no options. And if they don't type one of the no options, it'll go ahead and it'll create the list. So, how do we create our functional definitions so that this program is useful and not just for looking up if a file exists? Because while that's useful, the intent of this program is to be able to take whatever text file we enter the name for and add records, remove records, create and delete records. Alright. For that, we want to create first the file if the user if the user puts in a file name that doesn't exist. Oh, we've already been at this an hour and we've only gotten 2 functions. Okay, so that's fine. We did get through loops and conditions, so we're on a roll. Okay, to define your own function, and a function is just a bit of code that you can use again and again, and without having to type the whole thing out every time, because some functions can get to be kind of long. Like our file creation function. I don't remember if I saved that last one. Ah, yes, here we go. Remember our file writer? Remember how we opened and opened and opened and opened? What if we only had to do that once? Wouldn't that be cool? We just write our function for opening a file one time. And never had to do it again. I mean, there you go. We basically just did that. Now, every time we go with create file, it'll create the file, and it'll immediately close it. Not super helpful, but we should probably also make a couple changes. Like, first of all, we should pass it the file directory. As an argument, so it knows where to create that file. And we should also pass a file name, so it knows what to call that file. And then we can take this and go file dir. Okay. Now, what have we done here? We've created a function that will, well, create this file. Whatever file we pass using directory and name. All we gotta do is pass it a file name and pass it a directory in the reverse order. And since this function we're only going to be running when the file is not found, and we confirm that the user does want to in fact create it, I mean, we're basically done here. We don't have to write any sort of checks or anything. Well, it's opening everything in write mode, which means it'll overwrite any file that may have existed there, but we've already passed the check if the file doesn't exist. So we're good there. That creates a file. Now, this right here is where we define our function. We give it a label, just like a variable name. And then in these parentheses are the parameters, or the arguments, for our function. Within the code block, we use these names in place of the variables, or in place of the actual, things we're going to do. Now, these don't have to match anything out here. These are just placeholders for when we call our file, which I'll show you how to do right now. So, create the file now. If, we need to create a user input again. Oh, and by the way, you should always predefine your user input immediately before your input, so that it doesn't have something in there already. Because if we use this label again anywhere else, and we've already defined it, we've already given it some kind of name, like, that could really mess stuff up. Because say they said yes on the first time through, or no the first time through, and our function doesn't execute properly, we forget to set this up properly, and we get to here where it's going to be the input, and it's going to screw everything up. Make sure to clear out the variable before you're inputting it. Like, it's better. Let's see here. What was I doing here? Oh, right. So we have create confirm. If Create confirm. Or confirm create, rather. Ugh. I am super awesome at typing. Super awesome at typing. Ah, there we go. Okay. Let me explain what we've done here. Okay, so our if statement checks the value of our user input, and anything that isn't a no is going to be interpreted as a yes by default. So we came up with a list of valid no inputs, and we are going to test that user input against each of those. If it's found to be one of those, we're going to print out a message letting the user know that the file wasn't created. Basically, we've aborted that operation. It's not going to happen. No changes have been made. If we find that the input from the user does not match any of our no options, it'll create the file using our function up here. Now, we want to print some kind of success message. It's not just, good, that it does it, even though customer asked for it, the user specified that's what they want to happen. We want to give them some kind of feedback that it happened. Now, what I'm doing here is a bit of trickery. Like I said, we were going to revisit our print statements for something a little fancy. This right here is a special character that indicates that there is a variable that holds the value that we want there. Alright, and you've noticed we use that twice, so we'll need two variables. And this right here is telling this print statement where to pull those from. And this right here is just the list of those values that we're using. Same ones that were passed in here will be used here. Now we would use these file names, but these exist outside of our function. Within our function, we're using these because those are the labels that the values held by these got passed to when we called our function. See, we use file directory, the value in file directory, so this value here, when we call our function here, is plugged in right there. But when our function picks it up, it assigns that value to this label, and this is the label that gets used throughout our function. I hope that makes some kind of sense. Alright, if it doesn't, yell at me. But that's basically that is your file creation right there. That is your function creation. Alright, so enter a file name. We know kittens exists, so we're going to start with what we know exists. Alright, it's not giving us any options because it hasn't run into any problems yet, and we haven't started with the whole, do you want to make changes to this file, etc., etc., etc. Exit. We're going to try a default of no, just by hitting enter. Alright, there we go. I don't believe kangaroos exists in that directory. File not found. Create it now. We're going to go with the default yes. Now, as you can see here, file kangaroos.txt located in that directory has been created. And we can confirm, hey look, kangaroos now exist in this directory. So that's pretty neat. So that demonstration did a couple of things. It showed us how we can define some code to be used later. So we define it up here, we use it down here. Now, our kangaroos file is completely empty. So, what we want to do from this point on with our cruddy buddy to stay safe with things, we don't want to be overwriting any files. We've already created everything we need there. We want to simply be able to read them, append them, and change what exists, and delete the stuff that shouldn't be there. So we create the file, that's already done. But what about record creation? Alright, so before our exit strategy, we want to give the user some further options. Okay, we've gotten here, their file is created. Well, now what? We should probably give them a menu, right? Okay, so add a record, update a record, or delete a record. You know what? We should also just give the option of viewing a record, right? Actually, I have a better idea. What if it showed us what records were in that file before it even gave us the option of what to do with them? Alright, so in order to do this, we're going to need to do a couple of things. We're going to need to read the file. Now, we're going to assume our file isn't really that big, okay? It's going to have maybe 10 records. I mean, you know, we can scroll through that. That's not terrible. You could put a check in there where it'll print off 10 records, and then you hit a button, it'll print 10 more. That kind of thing if you want to. Now, for the purposes of our display here, we're just going to read the whole file at once, and then we're going to print it. Now, we're going to model this after our create file. And in fact, we're going to use a lot of the same language. All we got to do is change that to read. Now, you might be wondering, what's with this pass keyword I threw here? Anytime you're writing a function and you're not really done with it, if you throw this at the end, it indicates to the interpreter that it's not done yet. You intend to put more in there, but ignore that for now, because that's not what we're testing, that's not what we're looking at. I'd be able to run this, and even though this function really doesn't do much else, doesn't finish off this function like you would expect it to, I don't call it, I'm not using it anywhere, I could still run this and test it, you know? So, we want to read the file. And you remember how we did that with our kittens file? We just read the whole thing at once with read lines. We're going to do the same thing here. It would help if I could put the letters in the right order. There we go. All right. Now, this is introducing another new concept here, the return statement. If you write a function and you need it to do more than just, say, open and close a file within the same, bit of space, but you need to be able to use the values that were created within that function outside of it, you would return whatever value. In this case, the information that we read from the file, we're returning it to where we call it. So, how do we use that? How do we capture that information that's returned from our function? By assigning it to a value. You remember how our input takes in a prompt, and when the user types in something, it assigns that to whatever label we slapped in front of the equal sign? We're going to do a very similar thing right here. So, I'm going to change that though, because I want to use output outside the file. I like to use longer names outside of my functions, shorter names inside. I'm weird. I'm very weird when it comes to stuff. Alright, so we start by reading the file. We assign the output of that function a label so that we can refer to it. And just like the labels on the inside don't match necessarily the labels on the outside, same thing with the return statement. This file out is just a label we're using internally for the data that is pulled from the file. Whatever value this label has will be assigned to the label that we set our function equal to. Okay, so I could have this be anything. It doesn't have to resemble the name I'm using here. I'm just using that for simplicity, so I don't get confused when I'm looking at this and going, why, what is, what is this label for? Oh, file out? Well, that's obviously file output. And out here, file output. Okay, well that's the output of the file from reading it here, where I used it. But you can use any names you want for your labels. It's not going to confuse anybody. Now you remember our for statement? Before? Well, we're going to go for record in file output. And for now, we're simply going to print the record. Okay? We're not going to get super fancy. Now, file. This should all work in theory at this point. Now we'll test it with kittens again, because we know kittens works, kittens exists, kittens has stuff in it. And as you can see, Spaz, Spike, Tom, George, Spaz, Spike, Fluffy, and George. Alright, now I didn't put a prompt after my menu, so it just immediately defaults to the exit prompt instead of giving you an option to select one of these. But we're not done yet anyway. Okay, Kangaroos is empty. So because it's empty, there are no records to print. So that might be a little misleading or a little confusing. We could put an if statement here. Alright. So we'll save that. We'll run that again. No records. Okay. So that's a little clearer, you know. So now we've come to the whole adding records, updating records, deleting records part of things. Now we've already got the part where we can read all of the data that's currently in the file. And it exists as a list. And we can loop through it and read it. We also can manipulate the index of it to choose a record. So a lot of what we want to do, we already know how to do it. And we really don't need to do a whole lot of messing with the file itself. So we're really going to make that user input label work for us a lot. I mean, normally I would suggest coming up with, you know, different names. Like maybe menu input here because we're working with the menu. It doesn't really matter for our purposes. And there's not going to be a default option here. Not one automatically chosen. Oh, it's our highest one is 3. Alright. Now this seems a bit wordy, and it is. What I'm doing here is, as long as our user is being stubborn and not giving a, you know, an adequate response to the question of what option do you want, we're just going to keep asking. We're just going to keep asking. Now we've defaulted to no option, so it will go right into this. And the only way out of this loop is for them to choose something that is not just hitting enter and is a number greater than 1 or 1 and less than or equal to 3. Now, if our menu input label variable passes the check and we get out of this loop, we should execute the option that was chosen by our user. All right. Now we're gonna have to do more than just put these little hash, statements here. These are comments to remind us of what needs to go there. Okay. So we need to add a record. Now at this point, our entire file already exists in file output, which is a list. So we could just add to the list and then write that right back to the file that we've been working with. And that would add the record. So what I'm going to do here is first I'm going to create a second file creation, and this one's going to be slightly modified from the first one we made, because the first one we made just creates the file. With this one, the file technically already exists, but we're going to overwrite it with new data. And I want it to work where it takes the entire list of records that we already have, that we're already working with, and just rewrites that to the file. Now, I could just append to the file, and I would just have it take the one record that we want and just add that to it. And actually, you know what? That might be quicker. That might be easier. So yeah, we'll do that. That might be easier. But there are two options there. We can write all of the data we've been working with to the file, or, just the new record. Although, no, because if we just append to the file, we would also have to append to our record here. And we want to make sure that this matches the file. Let's see. We don't want to mess this up now, do we? Okay, so let's take a look at our flow here. Okay, so every time it prints out the records, it will have read everything to that. And then it asks us what we want to do. Now if we add a record, assuming we're just using our kittens and kangaroos and doggos as examples, all we're doing is adding names. You can make this more complicated with a split function, which allows you to take an entire list of values and split those up by, separating it out with a comma and join them back together as a single string. And we might get into that in another video, but we're running out of time here, so I just want to do this as we're just adding a name this time. We'll make it a little more advanced next time. So, add a record. Helps if I can spell things correctly. Okay. So we're going to get a name. We're going to add our new line character. And we want to write, or we want to append that to our already existing file output. So all right. And as you recall, with the read lines, the output is a list. Append allows us to just add to the end of that list. And that's the behavior we're looking for with adding a new record. So, what this is going to do is allow us to add a record, add a record, add a record to our list, but it doesn't add it to the file. Now, we could do that now. And honestly, we should. Like, we could just set it up here to when, just before we're done, we take all of the changes that have been made to our file output list and write them to file. But if this program were to crash before the user's done with it, we would want to make sure that all of their progress so far has been saved. So what we're going to do is we're going to do this write file, and I'm actually going to write the whole thing as a batch instead of appending the new information each time. How did we write our list? Just like that. But we're going to do it as a for loop. Alright, and then when we're done, we close the file. Alright. So where are we at here? We do, what do we call that? Write file? And we pass to it the directory. File name, enter file output. Is that gonna let me run it? It is. Okay. So, we know kangaroos exist now. We've already tested our file creation. No records, so let's add a record. Why did it jump to there? You know, let's take our loop out for a second. I don't think I did the checks quite right on that. So let's just do that. It's still not doing it right. What is going on here? Oh. That's why. So my checks were probably just fine with that while loop. I'll put that back in a moment. Okay. I mean, we don't really need that loop because it'll still loop through. Alright, choose a name. Jack. Alright, as you can see, our record does indicate we have one. Choose an option. Let's add another one. Let's, Kangaroo Jill. Jack, Jill. Okay. So, we only have 2 more methods to figure out. Alright. This one seems to be the one that's going to help us. Alright. Now, we're going to want to be able to identify the records as we're going through them. So let's see here. Where do we have it printing it out? Here's where we have it printing out. We're going to change this up a little bit. Okay. Now, I know it seems a little weird that we're altering this a bit. But I promise you, it'll make sense in a minute. I hope. Alright, so. We're still iterating through our file output. However, instead of doing it by item in the list, we're doing it through a range of numbers and using those numbers to index our file output. And the reason for that is because we need to give our records an identifier. And so as to not confuse the fine folks who will be using our program, we're changing these menu options to letters so they're not confused with records. But what this is going to do is it's going to print a record number, and it's going to print the name that's at that item index. Here, I'll show you. At least, I hope that's what it's going to do. Okay. At 0, we have Jack. At 1, we have Jill. If we choose A, George. I know we already used George for a kitten name, but that's fine. Now George is on there. 0, 1, 2. Alright. So we're doing good there. Now we want to update a specific record. We have options to choose from. If we want to delete a specific record, we have them as well. For deleting a specific record, that'll probably be easier. Because we'll just go with now, best practice, always have the default fail to the thing that doesn't make a change. Alright. Hey, welcome back. All right, now what we're going to do is now don't forget we need to turn that into a number, an integer to be exact. Otherwise it's going to say, you know, that's a string. You can't use that to index a list. All right. Now, once we've removed it from our file data, we want to write the new file data so that our file is still up to date, just like we did up here when we added a record. And we can even use the same file or the same function, same arguments. All right, so that's going to delete the file. And in much the same way, our update is going to be pretty similar. It's just going to be one slight change. Helps if I can type. Alright, and the same as how we reference the index down here, we want to reference that up here by converting the user input into an integer. And then write the file. Okay, so that's a lot of changes in a short amount of time. But we've just written a complete program. What does it do? Alright, well, welcome to CRUD, buddy. We need to work with our kangaroos list again. Alright, we have Jack, Jill, and George. Let's see what happens when we delete George. We're not done yet. Let's take a look at our kangaroos again. Jack and Jill. No George. George was successfully deleted. How awesome is that? Let's update. Let's update, you know what? Jill went down to the courthouse, changed her name to Jane. So now we have Jack and Jane. And finally, just because we tried the other two options, let's go ahead and add another one. Jack misses his best friend George, so he went out and found a new one named Bill. Oh, you know what? We forgot to add to our user's input there we go. Run that. We need to update record number 1 to just say Jane. Whoops. No, we don't need to. Oh, what happened here? Ah, you know what? After we canceled our file creation, we forgot to loop back up to where it's not done. And actually, you know what? just to make it easier, if we cancel file creation, just for now, we're going to go with exit the whole program. Run the module. Okay, so we have Jack, Jane. We needed to add Bill. Remember the extension. There we go. Jack, Jane, and Bill. We already know the updating and deleting of a record works. We know that we can do all kinds of stuff with it. Let's see. Thing is, though, we can't really exit our program from here, though. From this point. So we'll just have that default to an exit if they choose anything that isn't the option there. And we'll put a phony option up in here, but really, any option other than A, B, and C will exit you out of the program. There we go. Not exactly proper etiquette, but we're basically just trying to make a working program. It doesn't have to work perfectly. It just has to work. So, there you go. Let's play around with our kittens file from before. Remember these guys? Alright, so a couple of our buddies. Let's clean up this list. They exist more than once. Spaz is at number 4. You know what? Let's get rid of Spaz at number 4. Notice, we don't have 2 Spazes anymore. We do have 2 Spikes, though. Notice that the record's been updated to being at putting Spike at number 4. So let's delete that one. Are you sure? Yes. Exit. No. Spaz, Spike, Tom, George, Fluffy. We have another George. Let's delete that record at number 5. Are you sure? Yes. Exit. No. Alright. Spaz, Spike, Tom, George, and Fluffy. From our original list of kittens, we had Spaz, Spike, Tom, George, Spaz, Spike, Fluffy, and George. We're down to just the original names. Now let's say we want to add one. Albert. Albert. You know what? I've changed my mind. I don't like Albert. We're gonna change Albert to Dave. Why Dave? I don't know. Why not? Why not Dave? Ta-da! Alright. Exit kicks us out of the program. Let's run this one more time. This time, doggos. File not found. Create file now? Yes. File doggos.txt located in the proper directory has been created. No records. So let's add some records. Let's see. What should we call our first dog? Duke? Duke's been added. Alright, let's add another one. What's another good dog name? Anyone in chat got a dog name? I don't know if anyone's still in chat anymore. We're almost done here anyway. This is just testing out our Cruddy Buddy app that we wrote. We didn't get through all of the concepts that I wanted to try out. We still have objects. We did kind of revisit the file input-output. So I think we're done with that. We haven't dealt with objects, because there are some changes we can make to our little Cruddy Buddy once we learn about classes, but that's kind of a project in and of itself. Yeah, we'll probably want to cover that on its own. And then I'm going to show you how to import the library we've already kind of created here, because we technically created a library here. I mean, sort of. You know, we've got our create file, write file, and read file. We can use those in other places now that they exist. But that'll be for next time. I do want to thank you all for joining me again. Thanks for patiently following along as we worked our way through building this thing. This really weird and entirely useless text database program. You can extend on this. Feel free to look up how to do various things in Python to see if you can improve on this. I'd love to see what you guys come up with. By all means, I don't have any intent to patent this thing or anything. I mean, it's just an example. If you can improve on it, fantastic. I'm sure you can with just a few different concepts, instead of these individual lines just containing a name, as I said before, you could do separated, comma separated values, and using join and split, create columns for our little database here. I might show you how to do that next time, depending upon if we have time after discussing how objects work in programming. I do want to thank you all for joining me for this example on how to go about building a program out from scratch. Because that got pretty involved. But as you can see, it's not wizardry, it's just knowing how to do it. And now you know how to do it. So, enjoy your newfound skills. Come up with interesting ways to use them. And I will see you all next time. Have a great day.